We're going to be looking at how to write an equation and describe a pattern. And this goes into what we call linear equations. All right, so you'll notice that the outcome is generalizing a pattern that arises from a problem-solving context to use linear equations. So we're going to try to do that. So essentially what our goals are is to evaluate an equation, by determining the value of one of the variables if given the value of the other variable. We're going to try to figure out a pattern between those two variables if we have a table of values, and we're going to try to use a table of values to write an equation. Okay, that's what we're going to attempt to do. So to evaluate an equation, we actually also want to be able to do that, and to do that, we have to also be able to substitute values of one variable into the equation and see if it actually gives us the correct value of the second variable. So we've got a couple of different things that we're trying to do. We're trying to basically look at a question and either use an equation to predict, either extrapolate, which means go beyond the values that were given in a table or on a graph, or interpolate, which is to try to use the values in between values that were given in a table or a graph, or we're going to try to actually develop an equation from either a contextual problem or a table of values. So let's look at how we do that, all right? So the first thing we're going to do is we're going to look at equations and try to figure out how to use them to evaluate one variable from another. So you'll notice in this example, we're given different values, different equations, but we're given a value of d. We're told that d is equal to 4. So what you're going to do when you're using an equation is you're just going to replace wherever d is by 4, and we're going to see what that gives us for a value of c. So in this context, we go 4 times 4, and we get 16. Okay, in this context, we go 3 times 4 minus 5. We got to still follow order of operations, but that gives us 12 minus 5, and then 12 minus 5 is 7. So C is equal to 7. Okay, if we scroll down here, give a couple more examples. Here we have minus 2 times now D is replaced by 4, and then plus 3. So that gives us minus 8 plus 3. And minus 8 plus 3 is minus 5, so C is minus 5 here. And then finally here we go C is equal to 6 minus 7 times 4. And again, we're following order of operations, so 6 minus 28. Okay, we don't go 6 minus 7 and get 1 times 4. That's not following order of operations, although it is tempting for a lot of people. Okay, and then we get minus 22. So that's the idea of using an equation, right? Replacing a value for D and getting the value for C. The equation kind of describes the relationship. So then what we want to be able to do is actually take a relationship then and write an equation. So we know that we can do that. We can get a relationship. How do we do that? Okay. So we're going to look at a couple of different ways to do that. You can represent the relationship using a diagram, like a graph. You can use an expression, which is what we just looked at, an equation, or a table of values. Okay. So here's an example. So it says a landscape designer uses wooden boards as edging around plots in a garden, and the diagram below can be used to determine the relationship between the number of boards used in relation to the number of plots. Okay, and you'll notice the first thing we do is we assign a variable. So we're going to say number of boards, number of plots. Okay, and so the first thing we're going to do is we're going to use that table of values by saying here's one plot. Okay, here's 2 plots, 1, 2. Then there are 3 plots. Whoops, 1, 2, 3, and then finally 1, 2, 3, 4. So the number of plots, whoops, I can't getting ahead of myself. There we go. The number of plots goes like this. There's 1, then there's 2, then there's 3, then there's 4. Okay. Now we want to count the number of boards. So we can notice that there's 1, 2, 3, 4 boards for the first one. In the second one, there's 1, 2, 3, 4, and then 5, 6, and 7. So there's 7 boards in the next one. And then there's 1, 2, 3, 4, 5, 6, 7. Okay, and then we add 3 more. We're adding 3 more. So we get 10. And then finally, you can see again, the first plot, second plot, and third plot are the same. So we have these 10 boards here. And then we're adding 1, 2, 3 more. So we're going to have 13. So using our table of values, we should be able to write an equation. We can notice that first of all, I've sort of said this, but you can notice that these are jumping by 3, right, every time. We're adding 3. So essentially what we're doing, what we're going to say is that the number of boards is equal to 3 times the number of plots plus 1. Okay? 3 I'm getting from right here. And then I'm noticing that when B is 1, or sorry, when P is 1, when there's 1 plot, we get B is 3 times 1 plus 1. I'm just going to check to make sure that that works. So I'm adding that 1 because there's 4 to start. And then I'm going up by 3. So basically what we get, if you remember the term slope, or if you've heard that term before, and I'm not sure if you have, but that's the slope, and that's the starting point, okay? So we just sort of look at 4 and notice we got to add 1 to get 4 for the first block. So that's our equation, okay? And then you can always test your equation. That's the beauty of making an equation, is you can test it. So we could say, what about when P is 3? Does it work? Okay, so we go back to what we just did in the previous slide. We say 3 times 3 plus 1. Does that give me 10? Because it's supposed to, right? So we go 9 plus 1, we get 10. And we say, does that work? And we say, yep, there's 10. So that's our equation. Okay, so that's how we, first of all, take a diagram and describe that using a table of values, sort of list and count, and then from the table of values we develop an equation. All right. So here's another example. We have a banquet hall that has these square tables, and they seat one person on each side, and then when you push them together, you can start adding more people. So you notice at the first table there are 1, 2, 3, 4 chairs. So there's 4 people. Okay. And then when you pull two tables together, now you have 1, 2, 3, 4, 5, 6. So essentially what we've done is we've added these 2 people. All right, you notice? So we've added 2 people. We have 6 now. If we add a third table, we've added 2 more people. Okay? So now we have 8. So if we go to 4 tables, if we push 4 together, then we would add 2 more. We'd have 10. And then 5 tables, we would expect that we would have 12. Okay? So if we're going to create a table of values, the number of tables is first of all 1, then 2, then 3, then 4, and then 5. And the number of people is 4, then 6, then 8, then 10, and then 12. Okay? So hopefully you can see how we're doing that. You can count them, the first few, right? 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7, 8. If you want to actually continue to draw them, you can. But once we have this table, we should be able to describe the pattern, because what we can notice is this is jumping by 2 each time. We're jumping by 2. So that becomes the slope. In other words, we say that P is equal to 2 times n. All right, but what's 2 times 1? So we say when n is equal to 1, we get P is 2 times 1. We say that's 2, but it's not 2. You notice it's actually 4. So what we're going to do is to correct that is we're going to add 2. We're going to say it's 2n plus 2. Okay? And you can then check your equation. Okay? So in other words, I can, before I go down here and use it to predict something, I can say, what about when n is 4? Does this work? So I say P is 2 times 4 plus 2. Is that going to give me 10? I would expect, again, to get 10 at 4. All right? So I get 8 plus 2, and 8 plus 2, yes, it is 10. So we say, good. That does work. So now, how do we determine how many people can sit at 6 smaller tables? Well, that means, in our equation, that n is 6. So we say P is 2 times 6 plus 2, and that would give me 12 plus 2, which would be 14. Okay, so there's 14 people that can sit around 6 tables. If we do 10, same thing, it just means n is 10. So we go 2 times 10 plus 2. And that gives me 20 plus 2, which is 22. So we get P is equal to 22. So that's the idea of creating a table and then from a situation and then using that table to create an equation and then using that equation then to predict other pieces of information. All right. So let's look at another example. It says the cost for a basketball team to travel to a tournament includes a fixed cost of $200 on a tournament fee and then $25 a player to cover other costs. So we want to create a table of values. So here's what we're going to do. We're going to say if nobody comes, okay, if there are no players, all right, then obviously we would lose the tournament, but there's still that fixed cost of $200. So we're going to start, it's always $200 regardless. If one person comes, now we're adding $25 a player, okay? And if we do 2, then we get to 250. And then if we do 3, we get to 275. We're just adding 25 each time, right? Because every time we add a player, we're adding $25. And then, of course, if there were 4 players, there'd be 300. Now, depending if you're traveling with a basketball team, you need 5 players to field a team, to put them on field a team, I guess, put a team on the court. And you probably generally basketball teams are usually made up of 12 people. So if we want to look at putting together an equation, we're going to say the cost is $25 per player. Okay, so $25 times the number of players that are coming plus that $200 fixed fee. Okay, and if you look up here, if P is 0, that's how I know that I need that plus 200. Okay, and then it's adding 25 every time. So the 25, whatever you're adding, goes in front of this number, this letter, sorry, and then you add that ending just to sort of fix the start point. Okay, now it says, and here's my 12 players, right? How much is it going to cost for my sort of regular basketball team of 12 players to go? So I'm going to go 25 times 12 plus 200. So that's 300 plus 200. And that gives me $500. It's going to cost the team $500 to go to the tournament. Okay, and that's really the idea behind all of these. If you look at writing an equation, generally it's written as y and x. Okay, so when you sort of generalize this, you'll see it a lot more instead of p's and c's and things that we've been doing. You'll generally see y and then x. In front of the x is your rate of change. That's basically what are you adding each time. Okay, or subtracting, because you can have a negative rate of change. In other words, something can go down every time. And then this is your base amount or your fee. So in the last example, it was the $200. Okay, so it's like where do I start? It's the sort of starting value. If you're talking graphically, you're going to see this later. Okay, not right now, but this would be the slope. This is what it's called the slope on a graph, and this is the y-intercept. We'll talk more about that later on. You don't necessarily need to even know that for grade 9 math, but you should know that that's what those are really getting at, is that there's a base amount, there's a base fee if there's a base amount, or if it's sort of, when we said it's going up by 2, but the initial amount is 4, then we have to sort of correct for that. So that makes sure that that's corrected, and then this is where you're adding or subtracting. Okay, so here's an example. Given this table of values, we want to determine the pattern, and then once we have the pattern, we want to write the equation. Okay, so if you notice, the first thing I'm going to do is try to figure out what is this going up by. So this is plus 2, and then again plus 2, and then again plus 2. So that means if I add 2 again, I'm going to get 13, and if I add 2 again, I'm going to get 15. Okay, except, and this is where you have to be careful, and I did this intentionally to show you, this is going 1, 2, 3, 4, right? Then it jumped to 10. So we can't just go up by 2 here. It'd be nice if we could. We have to say, wait a second, I didn't notice that, so I need to fix it. So what I need to do in order to fill it in for 10 is I have to think about what's my equation. So the equation is the rate of change is 2, right? It's going up by 2, so 2x. And then I have to add my base amount. If you let x equal 1, this is how you check your base amount, all right? Then our y value should be 5. So if I just go y is equal to 2 times 1, I get 2. So to get from 2 to 5, I have to add 3. So this is going to be my equation, 2x plus 3. Okay. Now I can plug in 10, which is my x value that's there, and I'm going to get 23. I get 20 plus 3. So this is 23. Okay. And then I can plug in 12 and get 2 times 12 plus 3, and that's 24 plus 3, so that's 27. So I get 27 here. Okay, let's do another example. So here's another example. You notice again, it's going down by 2 now. All right, so it's going minus 2, minus 2, minus 2. So my equation is going to be y is equal to minus 2x plus something. All right, I got to figure out what that something is. So in order to do that, I take x equals 1, and I say y, if we just use minus 2x, I would get minus 2, right? But it's not minus 2. It's minus 1. So in order to get minus 2 to be minus 1, I have to add 1, which means this is going to be plus 1. So it's minus 2x plus 1. All right? So then we can fill in, once we know that, we can fill in 10 and get minus 20 plus 1, and that's going to be minus 19. And then when we plug in 12, we get y is minus 2 times 12 plus 1. And that's minus 24 plus 1, and that's minus 23. Okay, so we're using this pattern to find the equation. Once we have the equation, we're using it to, in this case, extrapolate. That is, we're using it to go beyond the numbers that we have to a bigger number, 10 and then 12. All right? And we can do the same thing. I'm not going to do these ones, C and D. I'm going to leave them for you to do. Okay, so there's, you can sort of see letter C. You can pause the video and try it. And then you can do the same thing here for letter D. And you can always test your equation. That's the nice thing about it, because if you go back here just to show you, if I say y is 2x plus 3, I can check to make sure that I get the right answer by saying what happens when x is 4 then? We go y is 2 times 4 plus 3. Well, that's 8 plus 3, which is 11. So I can say, does that actually match within my table? And I say, yep, the 11's right there. So I can be confident then that my equation's right. So I point that out to you only because then you can check your answer. You can see, did I do this correctly? All right, for both of those. So there's C and D, and I would encourage you to just pause the video and do them and see if you get the right answers. Okay, and then you're going to practice out of the textbook. And again, the textbook questions are going to be in the PDF that's going to be attached to this video. So I don't need to show you all of those, but there's a bunch of questions here, and they all do kind of the same thing. They show you a table of values, and they ask you to tell me what the equation is. Or they give you an equation and ask you to plug a number in, and then following that, they actually ask you to write out an equation and then use it to predict. Okay, so you'll see. And then they give you a couple of word problems. And all of that you should be able to do because we've covered all of that now in the video. And if you have questions, obviously you can follow up with your teacher.